The University of Arizona College of Science, Biosphere 2. The University of Arizona College of Science, Biosphere 2. Focus question. What is Biosphere 2 teaching scientists today? Introduction. Hi, I'm Beardy. I'm 10 and I'm from Tucson, Arizona. Sometimes I wonder what it would be like to travel to another planet. Not just what it would be like when I got there, but how life would be during the trip. Would I have enough food to eat and air to breathe? Would I get along with the other people on the spaceship? One group of scientists lived as people might on a giant spaceship. On September 26th, 1991, they entered a place called Biosphere 2 and didn't leave for 2 days. That's 730 days. Planet Earth is known as Biosphere 1. B2, which was designed to work like Earth, is 3 acres wide and in a big glass building, sort of like a gigantic greenhouse deep in the Arizona desert. 100,000 people visit B2 every year, and about 10,000 of them are students. Recently, B2's Deputy Director Joan Adams gave my mom and me a special behind-the-scenes tour. B2's history. On our walk to the dome, Joan explained B2's history. After men landed on the moon in the 1960s, people wondered how much farther humans could venture into space. Even if astronauts had enough fuel to reach a distant planet, sooner or later they'd run out of food and oxygen, unless they could make more along the way, could they? That question inspires the designers of B2. Construction began in 1987 and finished in 1991. B2 lacked a lot of things we Earthlings take for granted. With only 3 acres, the designers had to pick and choose what to include. Among other things, they chose a rainforest, an ocean, a desert, and a farm. They chose animals including goats, pigs, chickens, and bush babies. Last but not least, they chose 4 men and 4 women. Those 8 people had to raise their own food. It was a huge job getting everything from the ground and to the table, Jones said, and not all the farming succeeded. As a result, the people didn't have enough calories and lost a lot of weight. Living inside B2 was tough for other reasons too. Earth does all sorts of work for us. Joan called these natural services. It's work we depend on to stay alive, yet most of us take that work for granted. We are often unaware of it until we need it done. Imagine if we had to pollinate all of Earth's plants ourselves instead of relying on the wind and billions of insects. What a job that could be. Inside B2, they couldn't take those jobs for granted. Consider air. B2 is one of the world's most tightly sealed structures, leaking less than 10% of its air in each year. In 1991, the plants inside B2 were supposed to generate enough oxygen to match the air outside B2. Instead, the oxygen level kept dropping. The scientists inside started feeling exhausted. It was getting hard to move or even to remember their own names. Instead of doing experiments, they were just trying to survive. Finally, oxygen was piped in from a big truck. That solved the air problem, but by then the residents were arguing. Although they under stress, they stuck to the original plan and stayed inside for 2 years. The closed ecosystem didn't work flawlessly as the scientists had hoped, but they gathered important data and learned lessons about how to do things better in the future. B2 by the numbers. 7.2 million cubic feet. 203,881
cubic meters.
Cubic meters under sealed glasses. 6,500 windows. 91 feet, 27.7 meters tall at its highest point. Sealed from the earth below by the 500-ton, 453.6 metric ton welded stainless steel liner. Thousands of millions of wiring, pipes, and ductwork. Once that experiment was complete, the scientists knew that B2 was still a great opportunity for some kinds of research. But what? In 2007, the University of Arizona began conducting research inside Biosphere 2. The focus of the science there shifted from outer space to Earth. "We are going to go all over the world in just a few short steps," Jones said. "Are you ready for the rainforest?" The rainforest. Was I ever? We moved past trees so tall that they brushed the 91-foot, 28-meter ceiling. The long, streaky, brown roots of tropical vines hung down everywhere, looking like spaghetti. "This isn't a real rainforest," Jones said. "It's a lab where scientists can control manufacturers we can't control in the outside world." To demonstrate, he made one quick phone call. "I can't play weatherman inside B2, he said. Within minutes, it was raining. Here the scientists take soil samples and measure the rain and root growth. Soon, they will take all the rain out of the system and give the rainforest a 3-month drought. Scientists predict that dry spells like these could happen as earthworms. Creating one at B2 could help them know what to accept. In fact, much of the science at B2 today concerns changes to Earth's climate. However, as we walked out of that warm rain and headed toward the next biome, I wasn't thinking about climate change or global warming. I wanted to see the ocean." The ocean. We entered the ocean biome from a platform that looked down into 676,000 gallons, 2.56 million liters of salt water. The water was warm, nearly 80 degrees Fahrenheit, 27 degrees Celsius, and although B2's living creatures today are mainly plants, we saw colorful fish swimming there. Then we walked up a corridor and onto the beach. Gentle waves, made by a machine, not by wind, lapped the shore, and I spotted little crabs. I even got to hold one. We left the beach and, at the back of the ocean biome, picked in on a small mangrove swamp growing in the salt water. The air was humid until we passed through another door. Then suddenly the air felt hot, dry, and familiar. We were back in the desert. That's the magical thing about B2. With the turn of a doorknob, we move from one corner of the world into another. Our next stop wasn't another biome, though. It was a 50-foot, 15.24-meter high lawn. The lawn. If you put too much air in a balloon, it pops. The same ones applied to B2. Air pressure inside B2 built up as air expanded on hot days. To protect it, the engineers had to control that pressure. But how? We headed through a hatch-marked south long tunnel and entered a huge room that echoed like crazy. Back when B2 was still sealed, the lungs, there are two, just as in your body, equalized air pressure inside the structure. Its ceiling is actually a rubber membrane, like a 40,000-pound, 18,144 kilogram circus tent without poles to hold it up. So what does hold it up? Air pressure. During the day, the air inside B2 heats up and expands, pushing up the membrane. At night, the air pressure decreases and the membrane sinks down. When Joan opened the door, air whooshed out. We whooshed out too and continued on our tour. Research now. B2 scientists used to study how we might survive in other planets. Now, scientists at B2 look at living on this own with climate change. In the Landscape Evolution of Observatory LEO project, where we headed next, they're trying to figure that out. We entered the area that once was the farm. Here, scientists study how water interacts with land in 3 phases. In phase 1, the current place. They took more than 1,000,000 pounds of basalt, crushed volcanic rock, and arranged it on 3 slopes. They can make it raining here too. Over time, the basalt will turn into soil. Scientists want to know how long the change will take and under what conditions. Phase 2 sees how plants and water interact and how plants change the landscape's behavior. Phase 3 looks at how changes in water, in air temperature, moisture levels, and carbon dioxide influence the 3 massive hill slopes. John knows that breaking down rocks may seem pointless to some of us. It's really difficult for people to understand how these studies can be applied, he said. The scientists at B2 understand, though, just as B2 once gave them data about how life is in a closed ecosystem. Now it tells them what to accept about life on Earth as our climate continues to change. If we can anticipate, John said, then we can prepare, adapt, shift behavior. Hopefully, we could survive a changing climate. The climate is always changing, so why are people worried about climate change now? By burning fossil fuels, we create greenhouse gases such as carbon dioxide, that traps heat in our atmosphere. Many scientists now say that Earth is getting warmer and has been for many years. That heat may lead to more severe water, from hurricanes to droughts, and poorer quality habitat for wildlife. Changes in one place can lead to changes elsewhere. Earth's air, water, and land are all linked to the climate. Melting ice, for instance, leads to rising sea levels. Today, these changes are happening faster and on a bigger scale than anything modern humans have seen before. A lot to learn. As a 10-year-old, I still have plenty more to learn about science, but I understand why we do experiments. We want to discover things we don't already know. After all, any experiment can teach us something. In the case of B2, we learned that no matter how much money we spend, we still don't know how to engineer a long-term system that will give us everything we need in order to live. Yet Earth provides these services for free. We can't take Earth for granted and survive. In other words, B2 is great, but nothing beats B1.